Okay, so we have our running back running this way, 7 meters per second. We have our lineman running this way, 3. He's going to make the tackle, and as a group, they're going to move off at an angle here. Okay, and that's what we're looking for. All right, so just like we always do, we're going to say P initial equals P final. Okay, however, when we're dealing with 2 dimensions, because momentum is a vector, just like we always do with vectors, we're going to kind of isolate our horizontal directions and our vertical directions. Okay, so we're going to say P initial x equals P final x, and over here on the side we're going to also say P initial y equals P final y. So we're going to keep our 2 dimensions separate and isolated from each other. Okay, and so that's how we'll do this. That's how we're going to set it up. That's how it's different. So P initial x, so before they tackle, we have our running back, we have our lineman. However, only one of them is running in the x direction, right? That is the running back. So he's the only one that has an x momentum. So we'll say, all right, the momentum of the running back is in the x direction. Now afterwards they combine together, so we'll call this P, let's call it P combo, the combination. What type of collision is this, by the way? Completely inelastic. Yeah, completely inelastic. So this is going to be the P combo. So notice that the combination has a V final x velocity and a V final y velocity. So likewise, it has a momentum that is in the x direction and a momentum that's also in the y direction. So that's how we're going to kind of approach this conceptually. Okay, on this side, the lineman side, notice he's the only one that has a vertical momentum, so we'll call this P of the lineman. Again, that's going to equal P combo, but just the vertical combination. Okay, let's start doing some numbers here. Actually, let's just deal with the x first, and then we'll deal with the y. So this is going to be the mass of the running back times the velocity of the running back. That's going to combine together, so that means we're going to combine both masses. So the running back's mass plus the lineman's mass times V combo x. Right, the initial momentum of the line of the running back, 70 times 7. Okay, their combined masses, we have 70 plus 120. $190 VCX. Okay, this looks like it's about 2 point something. So again, what they're saying is of this pile of the 2 guys combined together, that's their horizontal velocity, 2.58. Okay, let's do the other side. Actually, why don't you see if you can do the other side without me? So I'll give you a head start. Find the y velocity of the pile. What are you getting? Okay, is that confirmed? 1.89? Actually, these are not the final answer though. What's the next final step?
We have to find the one at the end.
Okay, good. So we just found v final x. We find v final y. We now have to find the true v final, right? How do we get that? A squared, b squared, c squared. Okay, so we're going to do that. And then we also want to get the angle. So again, we're just going to use our triangle math to get to that. So 2.58 squared plus 1.89 squared equals v final squared. About 3 years. 2, 0. Okay, so that's going to be our hypotenuse here. Then we're going to do our tangent, right? Tan theta equals opposite VFY over adjacent. Theta equals what?
36.22.
And how do we say this angle?